Alright, continuing on differentiation, now we're going to look at chain rule. The chain rule is used to differentiate composite function. So if y is equal to g of f of x, where f of x, g of f of x is a composite function, and u is equal to f of x, dy by dx would be equal to dy by du multiplied by du by dx. So that is the chain rule. Alright, and you'll get a chance to see exactly how that works. Or if y is equal to g of f of x, then dy by dx is equal to, and again, f of x is, sorry, dy by dx would be equal to g prime of f of x multiplied by f prime of x. So if we consider, let's say, f of x to be the inside function and g of x to be the outside function, then chain rule is actually saying that we should what? First differentiate the outside function and multiply and then multiply by the differential of the inside function. So if we are differentiating a composite function, which essentially is one function inside of another function, chain rule says when we are differentiating that function, we must first differentiate the outside function and then multiply that by the differential of the inside function. Alright, so let's have a look at that in action. Alright, so example 2. I'm going to do it sort of using two approach. Essentially, it's the same thing, but one would be a little bit shorter than the other. Alright, so in approach 1, example 22 says, given that y is equal to 4x plus 3 raised to the power 8, we're to find dy by dx. Alright, so y being equal to 4x plus 3 raised to the power 8 here is a composite function. Alright, where so it's a composite function where literally I have one function inside of another function. So if I want, I could say let u be equal to 4x plus 3. So therefore, du by dx would be equal to 4 times the differential of x, which is 4 times 1, which is 4, plus the differential of 3, which is 0. When you differentiate a constant, the answer is 0. Now, y is equal to what? U raised to the power 8. Because remember, 4x plus 3 is actually equal to u. So now let's differentiate y with respect to u. dy by du would be equal to 8u to the power 7. So this is it's a power differentiation. So the power comes to the front, and then we have u, and the power decreases by 1. U to the power 7. Now, according to chain rule, dy by dx would be equal to dy by du multiplied by du by dx. Alright, so therefore dy by dx would be equal to dy by du, which is 8u to the 7th, multiplied by du by dx, which is 4. So essentially, this would be what? 4 times 8 is 32. U, but remember u is 4x plus 3 raised to the power 7. Alright, so this is sort of differentiating or the application of chain rule, sort of like almost like from a formula approach, all right, where we made the inside function u, then we differentiated what the inside function, then differentiated the outside function. And then chain rule is saying that the differential of the composite function would be the differential of the outside function, which is dy by du, multiplied by the differential of the inside function, which is du by dx. All right, now let us look at the same question but using a shorter approach. All right, so start with again with y is equal to 4x plus 3 raised to the power 8. All right, where 4x plus 3 is the inside function. Now, what chain rule says is that dy by dx would be the differential of the outside function. So the outside function is just a power differentiation. The power 8, the number 8 comes to the front, and the power decreases by 1. So this is 4x plus 3 raised to the power 7. Then we have to multiply now by the differential of the inside function. The inside function is 4x plus 3. When you differentiate 4x plus 3, you get what? 4. Alright? So this becomes 4 times 8 is 32. And then we have 4x plus 3 raised to the power 7. So as you can see clearly, it is a lot shorter. Alright? So what we have to remember is that when we are differentiating a composite function, chain rule says that we must what? First differentiate the outside function, then multiply by the differential of the inside function. Alright, let's have a look at another example. Again, using both approaches. Here we have what? Y, example 23 says, find the rate of change of y with respect to x given y is equal to 1 over the root of 7x minus 3. Alright, so again, when you're asked to find rate of change of y with respect to x, essentially what you're being asked is to find dy by dx, which is the gradient function. Alright, so y is equal to 1 over the root of 7x minus 3. This is y is equal to 7x minus 3 raised to the minus a half power. Alright, so whenever you're asked to find square root, the square root is the same as saying raised to the what? The half power. If the power is in the when the power is in, if the power is in the denominator and it's positive, when you bring it up, the sign of the power changes to negative. All right, and that is from a law of indices. So let's differentiate. Now, if I say let u be equal to 7x minus 3, I'm going to say du by dx would be equal to 7, because and differentiate what? 7x minus 3. It's 7 times the differential of x, which is 1, minus the differential of 3, which is 0. Alright. Y, again, would be equal to what? U to the minus a half power. This is a power differentiation, so let's differentiate. dy by dx, the power comes to the front, which is minus a half. U, and then the power decreases by 1, so that would be minus a half minus 1. So this would be dy by du. So I was wrong earlier. This should have been a u here. Dy by du. So this would be equal to minus a half u, which is what? 7x minus 3 raised to the minus 3 over 2 power. So minus a half minus 1 is minus 1.5, which is the same as saying minus 3 over 2. Now, dy by dx, alright, I mean the error again, this should be dy by du, would be equal to dy by du multiplied by du by dx. So dy by du is minus a half 7x minus 3 raised to the minus 3 over 2 power times du by dx, which is 7. So the answer here would be minus 7 at the top, and at the bottom we have 2 multiplied by 7x minus 3 to the positive 3 over 2 power. Alright, so if the power is at the top and it's negative, if you want the power positive, you bring it down to the denominator and change the power from negative to a positive. Alright, same question, a second approach. Alright, sort of like, as I said, sort of like almost a formula approach, a shortcut application of the chain rule. So again, y would be equal to 1 over the square root of 7x minus 3, which is the same as saying 1 over 7x minus 3 raised to the half power. Bring it up, we have y is equal to 7x minus 3 raised to the minus a half power. Now, dy by dx, chain rule, it would be the power comes to the front, so we're differentiating the outside function first. So it's minus a half that comes to the front. Then we have what, 7x minus 3. Now the power decreases by 1, so it's minus a half minus 1, which is minus 3 over 2, times now the differential of the inside function. The inside function is 7x minus 3. When you differentiate that, we get 7. So dy by dx would be equal to 7 at the top minus at the front, 2 in the denominator, and 7x minus 3, and the power is 3 over 2. Alright, so as I said, this is sort of like a shortcut application of the chain rule. Alright, in the first approach, we literally made the inside function, we call the inside function u, and we sort of like had a formula application of it. In approach 2, it's more direct, and it is what, shorter, a shorter approach to the application of chain rule. All right, let's do a few more. All right, example 24. Find the gradient function of y is equal to. All right, first of all, the gradient function is the gradient function dy by dx, or the first derivative, or the derivative is the the gradient function. All right, so let's write this is y is equal to 4 into 1 minus 5x to the power minus 6. All right, so here this is a composite function, and the inside function is 1 minus 5x. So let's differentiate dy by dx, which is the gradient function, is 4 times minus 6. So that minus 6 comes to the front. Then 1 minus 5x. The power decreases by 1. So it's minus 6 minus 1, which is minus 7. And then now we have to multiply by the differential of the inside function. The inside function is minus 1 minus 5x. When you differentiate that, you're going to get minus 5. So dy by dx, again, which is the gradient function, is equal to, this is minus 24, minus 24 times minus 5, that is positive 120. So this is 120 over 1 minus 5x to the power 7. Continuing, example 25 says, find the gradient of the curve y is equal to 4x plus 1 raised to the 2 third power when x is equal to 2. Alright, so we have y is equal to 4x plus 1 to the power 3 over 2. Alright, this is a composite function. We're asked to find the gradient. Dy by dx is the gradient function, which could be used, and the gradient function could be used now to calculate the gradient at any point on the curve or for any value of x. So dy by dx, chain rule, we're going to differentiate first the outside function. So we have the 3 over 2, the power comes to the front. Then we have what? 4x plus 1, the power decreases by 1. 3 over 2 is the same as 1.5. If you decrease the power by 1, it just becomes a half. Alright, and now we have to multiply by the differential of the inside function. The inside function is 4x plus 1. When we differentiate that, we're going to get 4. Alright, so here 2 cancels this 4 here, 2. So what we have is, we have 2 times 3 is what? 6. And we have what? 4x plus 1 raised to the half power. Alright, so I don't know why I have this way over here. Let's move this. I'm going to say when x is equal to 2, I'm going to get dy by dx would be equal to 6, 4 times 2 plus 1 raised to the half power. Alright, so this is what? 9. And the square root of 9 is, alright, now I see the boo-boo. Alright, so we made an error. Let's just go back and fix it quickly. It's not actually 3 over 2 at the top, it's 2 over 3. Alright, poor eyesight will cause you to do foolishness. Alright, so this is 2 over 3. Chain rule, dy by dx would be equal to, the power comes to the front, 2 over 3, 4x plus 1, the power decreases by 1, so it is now minus 1 over 3, multiplied by the differential of the inside function, which is 4. So now what we have is 8 at the top, and down by the bottom we have 3 into 4x plus 1 raised to the power 1/3. Alright, so now we're going to have what? Now we can say when x is equal to 2, we're going to have dy by dx is equal to 8 over 3 into 4 times 2 plus 1 raised to the 1/3 power. So this is 8 over 3 times 9 raised to the 1/3 power. And Obviously what you would simply do now is just use the calculator to work that out. I'm not going to do that. So let's have a look at example 26. Still in chain rule, we're to find the value of dy by dx at x is equal to 1. Alright, so we have y is equal to 4 minus 5x to the power 10. Chain rule, dy by dx. We're going to differentiate the outside function. The 10 comes to the front, so it's 10. Then we have what? 4 minus 5x. The power decreases by 1, that is 9. And you have to multiply now by the differential of the inside function, which is minus 5. The inside function is 4 minus 5x. When you differentiate 4, you get 0. When you differentiate minus 5x, you get minus 5. So this becomes minus 50. And then this is 4 minus 5x to the power 9. So when x is equal to 1, dy by dx would be equal to minus 50. 4 minus 5 times 1 raised to the power 9. So what we have there here is what? Minus 50 minus 1 to the power 9, which is minus 50 times minus 1, which is equal to positive 50. Alright, so minus 1, 1 raised to any power is what? 1. But if you raise a negative number to an odd power, the answer comes out negative. So minus 1 to the power 9 is minus 1. A negative times a negative is a positive. Alright, continuing. Still on chain rule. We have y is equal to 3x squared plus 2x plus 1 raised to the half power. Chain rule, the power comes to the front. Dy by dx, the power comes to the front, so you have 1 half. Then you have 3x squared plus 2x plus 1. The power decreases by 1, so that is a half minus 1, so that the power becomes minus a half. Then you have to multiply by the differential of the inside function. The inside function is 3x squared plus 2x plus 1. So when you differentiate 3x squared, you're going to get 6x. When you differentiate 2x, you're going to get 2. And when you differentiate 1, you're going to get 0. Whenever you differentiate a constant, you get 0. Alright, so what we have here is my 6x plus 2 goes to the top. So we have 6x plus 2. That goes to the top. At the bottom, I have what? 2 multiplied by 3x squared plus 2x plus 1 raised to the positive a half power. So the power was first negative, and to make it positive, I mean you carry it down to the denominator. Alright, so at the top, factor out the 2, you get 2. Then you have 3x plus 1. This is over 2 into 3x squared plus 2x plus 1 raised to the power a half. This 2 cancels this 2. We have dy by dx is 3x plus 1 over if I want, raising to the half power is the same as saying square root. the square root of 3x squared plus 2x plus 1.